Agile Development, Chapter 3, the Manifesto for Agile Software Development. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interaction over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is a value in the items on the right, we value items on the left more. And then that is according to Kent Ball et al. So what is agility? Effective, rapid, and adaptive response to change, team members, new technology, requirements, effective communication in structure and attitudes among all team members, technological and business people, software engineers, and managers. Drawing the customer into the team, eliminate us, and then attitude, planning in a uncertain world has its limits and plan must be flexible. Organizing a team so that it is in control of the work performed, eliminate all but the most essential work products and keep them lean. Emphasize on incremental delivery strategies as opposed to intermediate products that gets working software to the customer as rapidly as feasible. So, yielding rapid incremental delivery of software, the development guidelines stress delivery over analysis and design, although these activities are not discouraged, and active and continuous communication between developers and customers. So, why and what steps are agility important? So, why? The modern business environment is fast-paced and ever-changing. It represents a reasonable alternative to conventional software engineering. For certain classes of software project, it has been demonstrated to deliver successful systems quickly. And what may be the term as software engineering light, the basic activities communication, planning, modeling, construction, and development remain. But they morph into minimal tasks set that push the team toward construction and delivery sooner. The only really important work product is an operational software increment that is delivered. And agility and cost of change. Conventional wisdom is that the cost of change increases non-linearly. As project progresses, it is relatively easy to accommodate a change when a team is gathering requirements early in a project. If there are any changes, the cost of doing this work are minimal, but if the middle of validation testing, a stakeholder is requesting a major function change, then the change requires a modification to the architectural design, construction of a new components changes to other existing components, new testing and so on. Costs escalate quickly, and a well-designed agile process may flatten the cost of change curve by coupling incremental delivery with agile practices such as continuous unit testing and pair programming. Thus, team can accommodate changes late in software project without dramatic cost and time impact. Then, agility and cost change according to illustration, which is the development schedule process. As you can see, the progress of cost of change using agile process, and the other one is cost of change using conventional software process. So see the difference. And then another is the dotted, the idealized cost of change using agile process. An agile process is driven by customer description of what is required scenarios. Some assumptions recognizes that plans are short-lived, some requirements will persist, some will change, and customer priorities will change. Develop software iteratively with a heavy emphasis on construction activities. Design and construction are interleaved. Hard to say how much design is necessary before construction. Design models are proven as they are created. Analysis, design, construction, and testing are not predictable, thus has to adapt as changes occur due to unpredictably, delivers multiple software increments, deliver an operational prototype or portion of OS to collect customer feedback for adaptation. And agility principles, which is to part 1. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Second, welcome changing requirements even late in development. Agile process harness change it for the customer competitive advantage. Deliver working software frequently from a couple of weeks to a couple of months with a presence a preference to the short time scale. Fourth, businesses or business people and developers must work together daily throughout the project. Then fifth, build project around motivated individuals and give them the environment and support they need and trust them to get the job done. Sixth, the most efficient and effective method conveying information to and within a development team is face-to-face conversation. So let's go to second phase. Working software is primary measure of progress. Agile process promotes sustainable development. Sponsors, developers, and users should be able to maintain a constant pace indefinitely. And continuous attention to technical excellence and good design enhances agility. Simplicity, the art of maximizing the amount of work not done, is essential. The best architecture requirements and designs emerge from self-organizing teams. At regular intervals, the teams reflect on how to become more effective, then tunes and adjusts its behavior accordingly. So for the human factors, the process molds the needs of the people and team, not the other way around. So for the key traits must exist among the people on an agile team and the team itself. So for the competence, which is this is the skills, talent, knowledge, then the common focus, deliver a working software increment. For the collaboration, peers and stakeholders. Next, decision-making ability, freedom to control its own destiny. And for the fusive problem-solving ability, ambiguity and constant change today, problem may not be tomorrow's problem. And mutual trust and respect, self-organization, themselves for the work done, process for its local environment, the work schedule. And let's go to XP or extreme programming. So the most widely used agile process, originally proposed by Kent Beck in 2004, it uses an object-oriented approach. So for the XP planning, begins with the listening, leads to creation of user stories that describes required output features and functionality or the customer assigned value, example, priority to each story. Agile team assesses each story and assign a cost, development weeks. If more than weeks, customer asks to split into smaller stories. Working together, stories are grouped for a deliverable increment next released. A commitment, stories to be included, delivery date and other project matters is made. So we have three ways. So first, either all stories will be implemented in a few weeks. Second, high priority stories first, or third, riskiest stories will be implemented first. So after the first increment, project velocity, namely number of stories implemented during the first release, is used to help define subsequent delivery dates for other increments. Customer can add stories, delete existing stories, and change values of an existing story, split story as development work proceeds. So XP design occurs both before and after coding as refactoring is encouraged. Follow the KIS principle or keep it simple, nothing more, nothing less than the story. Encourage the use of CRC or responsibility collaborator, or which is the CORDS, in an object-oriented context. The only design work product of XP is they identify and organize the classes that are relevant to the current software increment, which is will be seen to chapter 8. And then for difficult design chapters, design the creation of spike solution, a design prototype for that portion is implemented and evaluated. Encourage refactoring and iterative refinement of the internal program design does not alter the external behavior yet improve the internal structure, minimize chance of bugs, more efficient, easy to read. So for the XP coding, recommends the construction of the unit test for story before coding commences. So the implementer can focus on what must be implemented to pass the test. So encourage pair programming. Two people work together at one workstation, real-time problem solving, real-time review for quality assurance, and take slightly different roles. So for the XP testing, all units tests are executed daily and ideally should be automated. Regression tests are conducted to the test current and previous component, and acceptance tests are defined by the customer and executed to assess customer visible functionality. And another figure show extreme programming or the XP, which is same as the waterfall. We have the planning, user stories, values, acceptance test criteria. Then for the design, simple design, which is the CRC chords, and spike solution prototypes, and it goes to coding, which is the pair programming and refactoring. And then, of course, goes to testing or the QA, quality assurance, which is they will test the unit. And as I mentioned earlier in the class, that here in the country, Philippines, sometimes companies are not being practice of we most companies here doesn't have QA. So in other part of the countries or companies, they strictly implement the QA. But here in the Philippines, we are a third world country, so sometimes companies are in as much as possible when it comes to costing or saving money or cost cutting. So sometimes they shift to unit testing. And then after that, release of software increment project velocity computed. So next, we have to XP debate. Requirements volatility. Customer is an active member of XP team. Changes to requirements are requested informally and frequently. Then for the conflicting customer needs, different customer needs need to be assimilated, different vision or beyond their authority. So we have the requirements are expressed informally. So user stories and acceptance tests are the only explicit manifestation of requirements. Also, we have a formal model may avoid inconsistencies and error before the system is built. So we have the proponent said changing nature makes such models absolute as soon as they are developed. And for the lack of formal design, XP then de-emphasize the need for architectural design, and we have the complex system needs overall structure to exhibit quality and maintainability. Proponents said incremental nature limits complexity as simplicity as core value. So let's go on to adaptive software development or the ASD. Originally proposed by Jim Highsmith in 2000, focusing on human collaboration and team self-organization as a technique to build complex software and system. For the ASD, distinguish these features. So we have the mission-driven planning, component-based focus, uses time boxing, which is been on chapter 24, explicit consideration of risk, emphasizes collaboration for requirements gathering, and emphasizes learning throughout the process. And we have the three P's of ASD. Speculation, project is initiated and adaptive cycle planning is conducted. Adaptive cycle planning uses project initiation information, the customer's mission statement, project constraints, or we have the example delivery date, the basic requirements to define the set of release cycles increments that will be required for the project. Based on the information obtained at the completion of the first cycle, the plan is reviewed and adjusted so that plan work better fits the reality. So for the second, collaboration are used to multiply their talent and creative output beyond absolute number. We have 1 plus 1 is greater than 2. Then it compasses communication and teamwork, but it also emphasizes individualism because individual creativity plays an important role in collaborative thinking. And then it's a matter of trust. One is criticized without animosity, assist without resentment, work as hard as or harder than they do, have the skill to self-contribute to the work at hand, communicate problems or concern in a way that leads to effective action. And then third, learning. As members of AST team begin to develop the components, the emphasis is on learning. Highsmith argues that software developers often overestimate their own understanding of the technology, the process, and the project, and that learning will help them to improve their level of real understanding. So again, three ways: focus groups, technical reviews, and project post-mortems. So another, as shown in another illustration, so adaptive software development. First, we have the speculation, which is adaptive cycle planning, uses mission statement, project constraint, basic requirement, time box release plan, and another requirements at requirements gathering JAD or the GAD, mini specs, which is the collaboration, and then after collaboration goes to learning. So for the learning components implemented, tested, focus groups for feedback, formal technical reviews and postmortems, and then release, software increment, adjust for subsequent cycles. And then for the dynamic systems development method, um, it is an agile software development approach that provides a framework for building and maintaining systems which meet tight time constraints through the use of incremental prototype in a controlled project environment. We are promoted by the DSDM consortium, which is dsdm.org, and it also distinguishes features, which is similar in most respects to XP or ASD. 9 guiding principle, and what are those? Active user involvement is imperative. DSDM teams must be empowered to make decisions. The focus is on frequent delivery of products. Fitness for business purpose is the essential criterion for acceptance of deliveries. Iterative and incremental development is necessary to converge on an accurate business solution. All changes during development are reversible. Requirements are baseline at high level, and testing testing integrated software life cycle. Sorry for that. No. Okay, so as you can see in the illustration, dynamic system development or DSDM. Sorry for the small screen. No. Here we have the stability, business study, agree plan, implement, and identity design prototype. So for the Scrum, let's go on. A software development method originally proposed by Swaber and Liddell, an activity occurs during a rugby match in early 90s. The rugby match class is like a football. Now, Scrum is distinguishing features. Development work is partitioned into packets. Then testing and documentation are ongoing as the product is constructed and work units occur in sprints and is derived from a backlog of existing changing prioritized requirements, and then changes are not introduced in sprint or short term but stable, but in backlog meetings are very short in 15 minutes daily, and some conduct without chairs. And what did you do since last meeting? What obstacles are you encountering? What do you plan to accomplish by next meeting? So also we have the demos are delivered to customer with time box allocated. May not contain all functions, so customers can evaluate and give feedbacks. So this shows the illustration of Scrum, or the Scrum process flow used with permission. Sorry for the picture. And let's go to Crystal, proposed by Cockburn and Highsmith. So Crystal, distinguishing features, actually a family process model that allow maneuverability based on problem characteristics. And we have the face-to-face communication is emphasized and suggests the use of reflection workshops to review the work habits of the team. So we have the feature-driven development, originally proposed by Peter Coad et al. As the object-oriented software engineering process model, or we have the FDD distinguished features. Emphasis is on defining features which can be organized hierarchically. A feature is client-valued function that can be implemented in 2 weeks or less. Use a feature template, which is here we have the action, result, buy, for, and so on. And then another, add the product to shopping cart, display a technical specification of the product, and store the shipping information information for the customer. And then a feature list is created, and plan by feature is conducted, and then the design and construct merge in FDD. So here another illustration printed with permission of Peter Coad. No? So we have here the develop on overall model. So next, build a feature list and plan by features. And then it goes to design by feature and build by feature. So let's go on to agile modeling on our last slide. Originally proposed by Scott Ambler, suggests a set of agile modeling principles. So models with a purpose use multiple models, travel light, and content is more important than representation. Know the models and the tools you use to create them and adapt locally. So that will end my slide, and then we will continue to next topic.